Hello. No? As for the second problem, so we have a given here a much more comprehensive transportation problem. So Sunchem, it is considering to to move its production and shipment of its goods to many places around the world. So that involves the US, the Germany, Japan, Brazil, and India. So all of these locations, they have their own production facilities and in which the shipments will be coming from. The destinations are the five continents, so North America, South America, Europe, Japan, and Asia. So they have the given is already the demand, no? The demand in terms of tons per year, as well as the capacity of each of the location given in tons per year. So as for the first constraint, it describes that each of the locations here, each of them, they must provide at least 50% minimum of the capacity. So what does that mean? It means that from this available capacity that is mentioned, no, they they must be able to ship, they must be able to produce, they must be able to hand out, no, their products at least half of this number right here. Uh, for instance, the US 185. So they must, as you can see right here, they must they must have output of at least half, which is 93. And uh, other data here is that these numbers right here below the location, they describe the individual costs of shipment to its destination. So that involves all of the locations right here. And as per the shipment, so how was this value computed? Well, this solution is already provided, and it it has been automatically computed through optimization programs. So we have the table right here. No? Have the final table given the constraint of minimum 50% capacity. And uh, from the observation, no, because every location must have at least, no, must fulfill the minimum capacity. There are some allocations of shipment that are more so than others. So for instance, in the US, the only shipment that is done is towards North America. So relatively close. It has a relatively low cost. And the reason why that is, no, it's the just a few allocations for shipment is that it has a relatively high production cost per ton. So, uh, despite the US being the gold standard, no, for the dollar, the exchange rate is uniform, but its exchange rate is really uniform. But compared to other places, there are simply more cost-effective options. And to compute that, no, to compute the production cost per ton, we just simply reference the given. So production cost per ton as well as the fixed exchange rate. So just multiply them, and then the production cost per ton is obtained. And as you may see, there it's varying. It's varying towards the all of the locations. So not every location is equal. So and in contrast, no, from the US, which has few, we have Germany right here. No? Not only it has it needs tons of capacity, but it maximizes it, no, in this instance. And the reason why is that, no, it has a relatively low production cost per ton. So compared to US, it has around $2,500 less of production. So it is able to produce more, to able to ship more, but not incurring as much of the production costs. So again, moving to Japan, it has fewer shipments than the US, and that's considering its high production cost per ton. So the same thing with Brazil, no? It uh, this time it prioritizes, no, South America, and with the relatively many, no, it maximized the capacity, and with minor fulfillment to North America. And as for India, since it is close to Asia, the system chose to allocate its shipment there. And that's it for the first half of this table right here. So to compute the total cost, uh, you have also need to consider the the production cost as well as the transportation cost. So and just summarize all of it up. This one production cost, it is computed by multiplying, no, multiplying all this as well, all of this given, as well as the capacity right here. So that's all of this for all of the locations. And then as for the transportation costs, similar to the last problem, you just multiply multiply all of the allocated shipments to its transportation cost. So just summarize it all it up, and that's the result right here. And then to total it up, just sum the production cost as with the transportation costs. So uh, in total, this is the total costs given the constraint. Now, moving on, no, to the second question, the it, the given is that the constraint that is put on earlier, it's not anymore. It's not existing anymore. It's removed. So how does that affect the table? Well, as you may see right here, the shipments that are allocated in the expensive production places, such as the US and Japan and India, they they don't exist anymore. When given no restrictions, the the allocations will gravitate towards the ones that have the lower costs, the lower production rates, the lower the lower costs. So, so the capacity right here, it pulls uh, all of the all of the available demand together into just a one singular place, which is Germany as well as Brazil. So in Germany, since it is relatively close to Europe, Japan, and Asia, so it it is the system chose to allocate it right here. And despite despite not filling it up exactly to the maximum, it's still cost effective in the long run. However, as we can see right here, there's a slight problem with Brazil. It it has it because it is one of the relatively lower costing places. It chose to allocate almost all of the demand here, close to the Americas. So the total amount of capacity that's demanded is greater than the available capacity, which that is a slight problem that needs to be overcome in some way. But that's the problem is limited to here. So that in another time na lang. And computing for the total cost, we can see that it is around it is around $500,000 less cost than the constraint than with the constraint right here. Now, as for the third question, so what if instead of restricting the capacity constraints to 50%, what if we added more to a single location? So that is Brazil. And the system determines that, uh, and it became slightly different. It's not the lowest costing option, but it is interesting how this unfolded. So instead of fully allocating the demand to a single location, it chose to split them up. So from the North America, it split them into US, Germany, and Brazil. And yeah, but the core principles of the core principles of the lower costing behavior, it still remain the same because ayan, majority of the shipments they come from Germany as well as Brazil. So, the exchange rate didn't change naman. So uh, the resulting production rate is still the same, still relatively low. But but in difference to the last problem which has no constraint, the capacity, the available capacity is balanced right here. No? It's not the production plant in Brazil doesn't need to overcompensate, which might incur additional costs. So it fulfills exactly the specifications of this problem right here. So uh, considering the total costs, it amounts to around 7.7 or $7.8 million. So given the ano, given the additional constraint, we managed to make a balanced problem that fulfills the shipments to be allocated at the lowest cost possible. So ayun. Uh, so the difference is that ayun, this one the first one that we tackled about, it incurred the highest total cost. But in the second one, it incurred the lowest total cost, but is problematic for being overcapacitated in one location. And in this third one, we managed to produce a balanced one that fulfills all of the capacity constraints, the demand constraints, as well as the production cost, optimizing for the lowest production cost per ton. Ayun. So, as for the final question, because the fixed currency rates, they cannot be really dependent on. So, they can account for the fluctuating rate by, firstly, converting the costs into forecasted, depending on forecasted rates. So, forecasting rates, it allows them to better anticipate whether whether certain currencies will be more favorable or not, and are able to adjust accordingly. And similarly, we can also use additional operations research tools such as sensitivity analysis. So sensitivity analysis allows to adjust the allocated shipments, to allows us to discover how much how much allocated shipments can be made without affecting the total cost or the optimality of the total cost. Yeah. So that is it for the second problem. I hope this has been helpful, and I think thank you for watching.